Welcome to today's Explainer. We're going to be exploring the architecture of trust today, specifically by looking at blockchain mechanics. But we're doing it through a slightly different lens. Instead of staring at endless streams of code, we're unpacking the source material by imagining these really cool, tactile, claymation-style visualizations. Just picture physical blocks of data and these vast interconnected networks that you can almost reach out and touch. Let's take this incredibly abstract digital concept and make it entirely concrete. So everything really starts with this one fundamental question. How do we build trust without a central authority? Just think about your digital life for a second. When you buy a coffee, transfer money, or sign a digital contract, you're relying on a central institution like a bank or a massive tech company to verify that transaction. They are the middlemen, right? They hold the master ledger. But what happens if that single centralized institution gets hacked? Or what if their servers just crash? Or honestly, what if they just make a human error? Relying on one central, vulnerable authority creates a massive, single point of failure. And that is the exact problem blockchain technology was built to solve.
Okay, let's dive into Section 1, the decentralized digital ledger, breaking down the basics.
At its absolute core, a blockchain is a decentralized and tamper-proof digital ledger that securely records transactions across a network. So instead of a single, dusty old book locked away in a bank vault somewhere, I want you to imagine physical clay data blocks that are copied and spread across a massive global network of thousands of computers simultaneously. Because there's no single central location holding the ledger, there's literally no single target for a hacker to attack. It's entirely decentralized, and as we're about to see, it's virtually impossible to tamper with.
Moving right along to Section 2, blocks, hashes, and security, the mechanics of the chain. Let's zoom in and walk through the exact life cycle of a single block. Step 1, the transaction data is stored. Think of this as our digital clay being molded to hold the details of a specific transfer. Then, Step 2 is where the magic really happens. A unique hash is generated. You can kind of think of a hash as a unique digital fingerprint pressed directly into that block of data. It's mathematically tied to the exact information inside. And finally, Step 3, the block is added to the secure chain. Now here's why that hash fingerprint is absolutely crucial. If a hacker tries to go back and alter the data in a previous block, the hash immediately changes. And because every single block is mathematically linked to the one right before it, changing one hash breaks the entire chain. That tampering becomes instantly, blindingly visible to everyone on the network. There's no hiding it.
Let's move to Section 3 and see how this builds, reaching consensus without bosses, validating the network.
So we are completely moving away from the old central authority model, relying on those vulnerable single intermediaries we talked about earlier. Instead, we're shifting toward consensus mechanisms. Instead of a boss or a bank manager making the call, the network uses complex mathematical rules to get all the computers to agree. The source material specifically highlights proof of work and proof of stake as the primary mechanisms for this independent verification. Now, without getting too deep into the weeds here, these are essentially just different mathematical ways that the network of computers independently double-checks the math behind every transaction before they agree to lock a new block into place.
Once that network consensus is reached, the results are incredibly powerful. Verified transactions become permanently stored across multiple nodes, which just means they exist securely on countless computers all at the exact same time. They are completely transparent, highly secure, and remarkably resistant to fraud. This consensus creates a cybersecurity environment that is just next level. It isn't just a digital record, it's a permanent mathematical lockbox. Once that data is verified and the block is chained, it is practically etched in stone.
Section 4, powering crypto and beyond, real-world utility.
Now, what's really interesting about this is how these exact mechanics serve as the engine for the decentralized financial shift. Blockchain is the foundational technology powering massive assets like Bitcoin and Ethereum. Because of those tamper-proof blocks and the network consensus we just broke down, users can execute incredibly fast peer-to-peer transactions globally. You can send value across the globe securely without a traditional bank taking a cut or slowing down the process as a middleman. The math entirely replaces the middleman.
And this brilliantly illustrates that the power of the chain goes way beyond just digital currency. Massive global sectors, we're talking logistics, healthcare, finance, real estate, they are all leveraging these secure, decentralized ledgers to completely revolutionize how they operate. They're using them for tracking highly sensitive supply chain data, managing automated digital contracts, and just improving overall transparency. Because honestly, a tamper-proof system is just as valuable for securing your medical records or the deed to your house as it is for securing a digital asset.
Zooming back out for Section 5,
The future of trust, advantages, challenges, and the bottom line.
So the crucial point here is that we have to impartially weigh the massive benefits against the very real challenges facing this tech. The advantages? They are revolutionary. Unprecedented transparency, true decentralization, and incredibly robust security. But the hurdles are definitely significant. Scalability remains a huge question. Like, can these networks really process millions of transactions a second, as fast as traditional credit cards? Furthermore, consensus mechanisms, particularly proof of work, can require astronomically high energy usage. And finally, evolving global regulations mean the legal landscape for these networks is still very much under construction all around the world. It's a real balancing act of immense potential versus practical growing pains.
But despite those challenges, the source material drives home a very clear bottom line. Blockchain technology is fundamentally transforming how trust, transactions, and digital systems work across industries worldwide. It isn't just some experimental concept anymore. It is actively reshaping the bedrock of our digital interactions. It's a profound, worldwide shift from trusting central human institutions to trusting decentralized mathematical consensus.
So, I want to leave you with a final thought to chew on. We've seen how the blocks are built, we've seen how hashes secure the chain, and how consensus totally replaces the middleman. The mechanics are absolutely sound. But as this continues to transform massive global industries, the ultimate question isn't really about the technology at all. It's about us. Are we truly ready to let go of our traditional middleman and just trust the code? Thank you so much for joining me for today's Explainer. Keep questioning, keep learning, and I'll catch you next time.